Greetings friends and welcome to this video. Here we will discuss how to make one thread wait for one or more other threads to complete before it continues its own execution using the Executors API. Now recall that in a prior tutorial we have already seen that when it comes to executors, it is actually the tasks that we are interested in rather than the threads. So it will be more appropriate to say that in this video we will see how to make one task wait for one or more other tasks to finish before it continues carrying out the rest of its own business. Now, in the previous tutorial, we had seen that the thread class provides a method called join for this purpose in the normal threads API. In the Executors API, however, the creators of Java have devoted a full-fledged independent class called countdown latch for this purpose. The waiting tasks and the awaited tasks synchronize on an object of countdown latch. As the name specifies, there is a countdown involved. While instantiating this class, you have to specify an initial count that should be greater than 0. All the waiting tasks call the await method on this latch. The await method blocks till the time the count in the latch becomes 0. So, the execution of all the threads that have called this method is suspended. Secondly, all the tasks that are being waited on call the method countdown on this latch after they have finished their business. Each invocation of countdown method decrements the count in the latch by 1. When all the awaited tasks finish and each of them has called the countdown method, the count in the latch becomes 0. This releases all the waiting threads and brings them out of the suspended state so that they can continue their execution. Any subsequent calls on await return immediately. Note that there is nothing stopping a task from calling countdown more than once on the same latch object. So, you can use the countdown latch class for both the scenarios, waiting for n number of tasks to finish or waiting for one task to finish n number of times. By the way, there is also a getCount method in the latch that you can call to know the current count value in the latch at any time. Let us code an example now. We have a skeleton class here by the name of joining executor threads that we will use as the main class for this example. We also need a task that works with countdown latch though, so let us create that task first. Minor updates in any of the existing tasks will do. So let us copy loop task D and create a new task called loop task I. Changing its ID first. Secondly, we need to provide this task an instance of countdown latch that we can do using its constructor. Next, we need to update the run method here so that it calls the countdown on latch after it completes its business. So let's do that. I have added a null check for the latch here before calling countdown. This is so that this task can be used without the latch too. Lastly, we do not need to control execution duration of this task from outside. We can just let it sleep for random duration instead of passing the duration from outside. So we can remove the sleep time parameter from the constructor here. This completes our task definition. Let us switch to the main class now. Here we are first going to create an instance of executor service and an instance of countdown latch. Then we are going to submit 4 tasks to it. Each of these tasks will get the latch instance. Then we are going to make the main thread wait for those 4 tasks to finish before the main thread can continue on. Let's code it in. Here we have initialized the countdown latch with a count of 4, as we want the main thread to wait for all the 4 tasks to finish before continuing. Let's give it a run. From the output, we see that all the 4 tasks had started executing in their individual threads. And then all the 4 tasks ended one by one. After the end of each task, the latch count has decreased by 1. So as soon as the last running task ended, the latch count reached 0 and the main thread was released from suspension. After that, we see the message from the main thread that it has got the signal to continue, and then the main thread also ends. Now, what if the main thread wants to wait only for tasks 2 and 3 to complete and is not interested in any other tasks? For this, just set the initial latch count as 2 and don't give the latch to tasks 1 and 4 like this. Running it again. So as usual, all the 4 tasks had started in their separate threads simultaneously. And then task 4 has finished, in which our main thread is not interested. And then task 1 has finished, in which our main thread is not interested. And then task 3 finished, and after task 3 finished, the latch count was decreased by 1 and it became 1. Then task 2 finished, and as soon as task 2 finished, it also decreased the latch count by 1, thereby making the latch count 0. And immediately after that, the main thread was released. The main thread actually executed before the task 2 could print its latch count. So the main thread printed, got the signal to continue, and then ended. And lastly, we see the message from task 2 that the latch count has reached 0. And then the program ends. Now, what if the main thread wants to wait for any 2 rather than specific 2 tasks to finish before it can continue its execution? What I mean is that if we give the latch to all the tasks, but the main thread wants to continue its execution as soon as any 2 tasks finish, then how will you do this? That's easy again. Just give the latch to all the 4 tasks and let the initial latch count remain as 2. Like this. So let's run it again. So as usual, all the 4 tasks have started executing in their individual threads. And then tasks 4 and 3 end first. And after that, the latch count has reached 0, thereby releasing the main thread. So the main thread continues its execution and then ends. The other tasks continue executing, and when they finish, they also call the countdown method, but the count stays 0 and does not drop below it. That is normal. This is how the countdown latch behaves. Well, with that, we have reached the end of this video. See you in the next one now. Take care and bye.